Hi everyone. Today I'm going to talk about one of the most impactful papers in deep learning, uh, which is deep residual learning for image recognition, also known as the ResNet paper. It introduced a powerful architecture that has become the foundation of most modern computer vision models. So, in 2015, deep networks were failing to improve performance, and that's why at the time, in this paper, researchers were trying to train very deep neural networks, but they found a strange issue. Deeper networks were not just overfitting, they were actually performing worse both training and test sets. This paper proposed a simple idea that changed everything. Instead of learning directly mappings, they let the network learn just residues of previous layers, which significantly reduce the time of training and also increase the efficiency of training models. So the reason why deep networks does, didn't perform very well is because of the degradation problem was puzzling. Even though more layers should, in theory, means more modeling power, but actually in practice, they made optimization harder. The network couldn't coverage properly. This suggests the need for a new kind of architecture. That's why they brought up ResNet as the solution of this issue. So the key idea is to reframe that the network reframe only the what the network learns instead of forcing it to learn a full transformation. They just let it learn the difference between the input and output. This makes learning much easier and encourage the model to find better gradients to flow through the network. Here's what residue blocks looks like. The input go through a few layers, but it also skips those layers and add directly to the output. As you can see, the X and identity here means. So those identical features were just skipped those weight layers and then directly was concatenated at the end before output. Um, if the network doesn't learn anything useful, it just passes the input through. So this is why deep residue networks are so stable. And this chart from the paper shows the training curve for plain versus residue networks. The residue network not only achieved lower training loss, but they also generalized better. So the shortcut isn't just a trick, it actually improves learning in both performance and also in efficiency. Um, the authors scale this design up to a very deep model, including ResNet 34, 50, 101, and even all the way up to 152, which has 152 layers. And because of they use the residue design, they could go and that deep without training collapse. Each residue box follows a clean, repeatable structure using ReLU and batch norm. So the result was impressive that ResNet 152 actually achieved 3.5% top 5 error on ImageNet, which is still one of the largest image database data set we have. And it was more efficient than deep VGG models and won the 2015 RLS VRC classification challenge. So talking about real world um, impacts, the influence of this paper has been enormous. Many model architectures build upon its ideas. Even in transformers, residue connections are used. With over 100,000 citations, it's currently one of the most impactful papers in machine learning. And also nowadays we still have dense nets, UNet++, and also other variants of computer vision models built up was inspired by the idea of ResNet, and also it's why it's the backbone of the most of computer vision models nowadays is because its efficiency and also it decrease the limitation bar of the hardware requirements of training computer vision and or general AI models nowadays. So make AI models more useful to people. Yep. Thank you. That's my presentation today.